begin. You already know my name. You know that I work for our systems. I'm a software developer and an architect. I'm doing hands-on DevOps, and over the years, I've seen a lot of changes happen in this area. So today we'll talk about our approach for existing Java code, the journey through the tools used, the problems encountered, and the advantages we noticed with each change. This is not a hands-on presentation, so for each of the tools shown here in this presentation, there are several presentations where sample programs are being deployed and similar. This is about the experience of integrating and deploying a complex system written mostly in Java with the good and the bad. So let's see. But first of all, a quick reminder about our tech quiz, where you can win 3 Amazon e-cards. You can find it on our Expo Hall page in the Codecamp application. So next, one question. What should be continuously integrated? And before you say everything, we've got multiple points of view. So from a development point of view, you should integrate code into the repository frequently. It will then be built automatically and hopefully, but not implicit, tested automatically. While from an ops point of view, you should integrate changes to your orchestration templates, which are used for the deployment of VMs, containers, and also integrate changes to your Ansible playbooks or variants thereof. These are the elements that are necessary for the node, be that a VM or a container, to be operated, for an upgrade, for healing a node that went down, etc. So, is it up to you, the programmer, to build the code before you commit, or should you rely on CI automatization? Well, for the software, let's begin with the software. Before the DevOps merge, it was clear: compile your code locally, then commit. Now, it's not so easy. You may compile the module you're working on, but when it gets compiled as part of the whole project, side effects may show up. Now it's no longer enough that your jar file gets generated. It needs to install successfully too. Now, this is the CD part. Still, you should not commit completely broken code, just that it's easier to break it without noticing. And now let's move to ops. Let's take playbooks, Ansible. Ansible, around since 2012, 2 years after OpenStack, 1 or so year before Docker. I can use it locally to install or configure additional software on my machine without any virtualization involved whatsoever. But it's much more useful for completing the installation of a node, like a VM or a container. It can be run from a Jenkins job or something similar. But then, running an Ansible playbook on your development machine to deploy a container in, say, I don't know, Docker for Windows, is hardly a proof that it will perform properly from the Jenkins job. So locally, not enough. But now that we have discussed the CI part, let's move to CD. But what is the point of these slides? The point is the importance of CI and CD on an environment that is as similar to production as possible. So, CD, what should be continuously deployed? But first of all, what is the purpose? But even before that, what is the D? Is it deployment? Is it delivery? Well, let's turn to Wiki like everybody nowadays, and it says that continuous deployment requires continuous delivery, meaning that to install that jar file, you need to generate it. Except that it's not just a jar file, it's usually an orchestration template with a playbook to get all the dependencies and the configuration necessary for that jar file. The consistent fact in continuous delivery is that any version could end up on the customer's system, unless you broke the software build or something in the ops part. So, what makes a CICD good? If compiling and testing takes literally the whole night, I may be sleeping by the time it tells me that I broke something. So, plus it's kind of breaking the mojo. I want to do my work now, not tomorrow. So that's the speed. And second is the reliability. So from a reliability point of view, I don't want it to crash because it's put together with spit grit and a lot of duct tape. Not everybody from the dev part embraced the ops part. So, for example, I may not know how to fix some broken YAML file, or I may not know why an image doesn't have the proper tag that I need to deploy it. But all in all, the advantage of having an established CI/CD line comes in pretty early during a project. So let's consider, for example, taking over a new project, either internally in the company or from somebody else. So have you ever found yourself in the middle of dependency hell, like install this, but then before you need to install that and so on? While you go through the README markdown files that are in each sub-project, you may encounter contradictory references. And I don't know, the next step is then to run the unit tests. Do they have any dependencies? Do they run both from the local machine and remotely from that Jenkins task that is available to do just that? Well, yes, unit tests should rely on mocks, and they should be able to run anytime and anywhere. But yeah, that's not always the case. So, bottom line, the first thing that I look for in an existing project, for me that works, is a short README file that tells me where to find the CI/CD pipeline and how to run it. That's it. From this, I can derive my own dev deployment, deliver artifacts, and so on. But enough with the generic stuff. Let's see some of the problems that we encountered. So first, some of our customers have their own code repositories, and they don't appreciate us stuffing them full of ops-related scripts. Next, Java that's not exactly Pony Express when it comes to compilation time. May even makes it even worse, so on. Next, depending on whether you create the whole test system, like you create it anew, your deployment speed may vary based on your technology. If that's a container, if that's a VM. Next one, you don't always run a component and have all the mocks around it, like we discussed in the previous slide. What about long-running test systems? And I'm looking at virtual machines here. And you may have just upgraded the version of some third-party program, and by the time you reach the production system, you forgot about it, and suddenly the code doesn't work. And last but not least, reporting. Everybody loves a good report, so that is full of tests that have hopefully passed. So, just a recap. The problems mentioned here are encountered when we already have a CICD line. For example, the separation between project code and ops stuff, that's not really a concern when you have no ops to talk about. You just have some README file that tells you how to install and configure your software. But now let's take a sample project from the telecom world. This is a pretty old one, but with several rewrites along the way. Ecosystem, that's another word for microservices that are not so micro. Dependencies, well, no mobile operator has ever replaced their entire stack of applications at once. Plus, there is no single vendor for it. You may have the control from Metaswitch, charging from SAP, soft switches from Sonos, I don't know. So most of the time, you won't even be replacing all the applications inside the project at once, because it's just too much for the customer's testing team to evaluate in one go. And the purpose here is don't do harm. First of all, don't break it. So let's check out our sample project here. This is a simplified view. First, on the left-hand side, we've got the front end to control some settings. On top, we have the external telco equipment that's sending requests to our gateway, which are then passed to the backend, which queries some databases. For example, HLR, which is the home location register, keeps the subscriber data, some of it, and then pushes some result to a partner on the right-hand side or to some other telco equipment. I chose this example because this one sits in the middle between entities which are provided by other vendors and is therefore most prone to the usual problems related to functional testing. So, what this comprises of is databases, HLR, like I mentioned, the multimedia system. We've got the front end for the operators, engineers to change configuration values. We have the backends which process and send info to the external systems with storage currently in Cassandra database. We have the statistics with the ELK stack, Logstash for input, Elastic for aggregation, Kibana interface, all the usual stuff. And we have a message queue that is built in Java. All of this is supported by our systems test tool, which is based on JMeter, and that does the functional testing. And for a couple of telecom specific stuff, we've got here the PCRF, policy and charging rules function, which we'll see in a later slide, SMS center, and GGSN for data, the gateway for data. So one use case. The simple one is GGSN, the gateway for data, so GGSN, sends an event, reduction in quality of service after the user has surpassed a certain threshold. For example, you've got 10 gigabytes on your mobile data per month, and you just surpassed that value. So how does this happen? By provisioning the PCRF, policy and control function, with the new reduced speed profile. I don't know, some reduced speed here. Meanwhile, the partner is informed, whatever is the partner of the mobile operator, and it can choose to show the subscriber a captive portal. So, for example, upsell. You can buy this package to add an additional 10 gigabytes to your profile. Or at least you get a notification via SMS. Anything could work. So let's have a look at our previous deployment. But first, some clarifications. We have here physical network function that is being moved to virtual network function and then later to cloud native network function. So what we had first were some pet VMs, pet as in requiring a lot of attention and care, manual maintenance. Why? Because it was simply easier. If you feel like you won't have to do the same job again, do it manually and be done with it. So in order to install software and make it permanent, the choice was either to open the virtual machine, install the software, close it back up and use the image, or use guestfish instead. This allows the VMs to run software with very little modification from the original physical deployment. And then there was OpenStack and cattle VMs. Cattle as in they don't require so much maintenance. And we treat them all the same. So for the test deployment, we were using OpenStack with orchestration. This was done in two ways, with Heat and Terraform. The choice of OpenStack was mainly due to having local hardware to deploy it on, and due to security concerns, mostly coming from the customer. Heat gave us the latest feature set because it's OpenStack's own format, and Terraform gave us the feeling that we could break it out into a public cloud if needs be later on. But anyway, at least the resources anyway have to change, as you can see in this example on the screen. So the advantage was that we were working with images as they were provided by their vendor, be that Red Hat, CentOS, or whatever. No pre-processing, meaning that we were ready to update whenever that vendor releases a new image. However, this was a pretty long deployment process. But by this time, we are done with the VNF instantiation and the management setup. And all of this is called Day Zero in ETSI, so European Telco Standards Institute, MAINO standard, that is management and orchestration standard. So they define Day Zero as in where you brought up your virtual machine container, whatever. And then when you're done, for example, you may find out that your cloud init is not enough for all the ops that you want to do, install software and so on. And in comes Chef, for example, to help you install the rest of the way, or Ansible. All of this could be triggered two ways, from a Jenkins job with a push, so classic Ansible if you want to talk Ansible, or from the cloud init of the virtual machine, and that is Ansible pool, or Chef works the same way. And once you have completed this, so you have installed all the additional software, the actual telco software on the machine, you are done with what is called Day One in the management and orchestration standard of ETSI, European Telco Standard. So that's a picture of OpenStack Horizon and how it looks like on how it looked like on our test system. With a virtual machine, you always have in mind the cost, time-wise, to bring it up. So you wonder if you really need to bring it down afterwards, or you could just reuse it by installing some new software on top of the existing one. And that's when you go into that, remember on the problems list, the unreproducible behavior. So one solution to this is the OpenStack approach, where you have the root drive is ephemeral, so it gets recreated every time you deploy the virtual machine. And while your permanent storage is on a Cinder drive, where you keep your config files, logs, whatever you want to keep. This kind of mimics the container behavior. No upgrade in place is possible, you simply have to redeploy. But then again, it comes down to how long it takes. And that's the problem with the virtual machines. One additional note, of course, you need a repository for binaries. If you deliver YUM RPM packages, you need a YUM repository to be available. So we discussed that it takes a long time to initialize virtual machines and install everything. Let's see about the step into CNF, Cloud Native Network Function. The main advantage, for example, for Docker Compose, we have the main advantage that it allows you to build directly. You just point it to a Docker file, and whenever you do a change in the Docker file, it will build everything anew. Of course, this can open a can of worms. You can do a small change, like a line in a config file in the Docker file, and you get a new image created with an ever slight difference from the previous one. So, separating the container building part from running them, that makes you find better solutions. And Docker Stack does exactly that. It doesn't allow you to build from Docker file directly, rather from images. The bad part is just one thing about Docker, the Swarm, the cluster version. The bad part is that nobody's providing it as a service anymore. Everybody seems to have moved on some other platforms, as we will see. So let's see our current deployment. After a lot of checks and balances, we decided to go with Openshift. And this is what our pods look like in one of our test instances. This means that every time we start a CICD pipeline, everything is newly built and deployed. We chose this approach in order to have a local implementation, again, due to cost and security concerns, and due to having a budget for the physical machines to run this on. This means that you don't have to worry about renting, but you still have to watch the efficiency, meaning you have to make the most out of the hardware that you have. So let's go back to our problem list. These are the problems that were solved by using this approach, the crossed out ones. What is the point here? Deployment speed. You may not care about the time it takes to deploy some small project, but as, for example, small companies, they tend to do away with hosting their own physical hardware. So you will eventually find yourself in the position of having to justify the size of the virtual hardware you need to rent from a cloud provider. What about the long, not to mention the disadvantage of that it takes a long time. I mean, yeah, you may want to see how it behaves immediately. The other thing is long-running systems. We no longer have them. Of course, you may choose to rent virtual machines and simply redeploy without bothering with containers. But yeah, do you really want to do that? I mean, after a couple of redeployments, your system may end up in a state where you are unable to replicate some failure due to several installs, one on top of the other. So, next thing. We are currently running Jenkins with a pipeline with a shell script behind it. The advantage of the shell script is that it can be versioned in some code repository, Git, whatever. So in this sample, you can see how we prepare the environment, the kube config stuff. We start the environment and we install the Maven part, libraries, settings, and so on, in order to prepare for the compilation of a Java project. Now, Jenkins is old news. Probably everybody has heard or used it ever. But there is always the possibility of using GitLab CI if you use GitLab. And there are other choices as well. So basically, we run a container where we compile the component and we unit test it. And the purpose is to avoid whatever Java version you have installed on the Jenkins machine itself, version which may be pegged to the version of Jenkins, I don't know. Instead, always rely on a freshly installed Java inside the container you just created. We use Jacoco for coverage measurements, and at the end of the Maven task, we pull the Jacoco exec files in order to use them for the report. Coverage of unit tests is one of the few, okay, they are synthetic, but is one of the few measurements that can give you some quantifiable way of telling how you expect a software to perform. So they are important. Of course, there are multiple frameworks available. In our case, we'll see why we chose Jacoco in the later slides. So one more problem solved. Now we have a separate project for the code and a separate project for CICD, the one that brings up everything and starts the compilation. So you may now ask, why do you bother? Just keep it all in there. And the answer is that it depends on what you need to deliver. So you may find yourself delivering software the old-fashioned way, like in a jar, in an RPM file, but this doesn't have to stop you from implementing a good CI/CD pipeline for your test system, if not for anything else. Production systems are notoriously finicky, so they may not allow you to install everything, not automatically, but test systems, on the other hand, everybody would love to have them provisioned with all the new software as fast as possible. I mean, no question about that. So next, we build the Docker images and we push them into Nexus or JFrog, the same way you wouldn't collaboratively develop nowadays without a repository like Git, for example, the same way you wouldn't do without a repository for Docker images, local one, or use Hub Docker, or I don't know. So we continue the pipeline with running a suite of a few functional tests, and for this we are using our JMeter-based test tool. For the functional tests to work, we run the containers from all the images that we created earlier. All of them work together. So here is what the testing tool looks like. It allows you to provision all the necessary data. So subscriber data, you've got provisioning requests to network elements, which may be simulated. And finally, you've got the actual test requests that are being sent. All of them are written using Groovy scripts. And yeah, it's nice because it's the kind of tool where you don't need a lot of previous experience. You can gain experience as you go using starting from some simple test scenario. Basically, you can send any request from some plain HTTP, so you can make JMeter behave the same way as curl. Or some SOAP or some diameter multi-threaded requests with some configurable. And everything is configurable, so you can ramp up your requests, do performance testing, anything that is required. So remember those Jacoco exec files from unit testing? Now we pull them together with the ones from functional testing. And the next step in the pipeline is to create the coverage report. So now we come back to our choice of Jacoco. Our build coverage for the sample project is a mix of unit and functional testing. So it was important for us to be able to combine the results and report on the code lines covered by each, or covered by both. Why not? The HTML output is useful and quite user-friendly. So here is a sample flow for the coverage. So we have 5 workers, which are full software deployments, which are separated, each one in its own namespace. Each worker has multiple pods, 9 pods in our case, because we have 9 components. So we take the Docker images, deploy them on each worker. After that, we run in parallel multiple tests using JMeter. When all the tests are finished, we extract all the Jacoco files for each pod, and we generate this code coverage report that you've seen in the previous slide. So, and at the end, of course, we generate some summary and we archive the logs for future reference. So back to compilation, just for one moment. So currently we are using a Docker daemon running on the Jenkins machine, but in the future we are planning to move to using Canico. So see the bold lines in the slide. This will allow us to have fewer dependencies on the software that is installed on the host machine. That's the end goal here, to run it on any host machine. So we can only have the software that is specifically required for Jenkins on the Jenkins machine itself, and we could easily move between Jenkins and GitLab Runner, for example. I know that migrating between frameworks is no easy task, especially for large projects, but the first condition to be able to do so is to have no dependencies that are specific to the framework. So actually, we are using both Jenkins and GitLab. And yeah, but I'm sure there are a few papers on the internet with the sole focus of comparing those two. So references are available. Additionally, what we have created is also the Helm charts so that we can make it more consistent. So be able to deploy all the components together in a certain order with certain conditions. Reusability was the first thing that we had in mind here. So back to our list of problems. One more problem solved. We now have a consistent coverage report. Well, I guess for many in the audience, a coverage report is one of the deliverables for any project. So that's important. So going back to our sample project, now that we have seen the pipeline, let's go back and discuss how we can test it using some sample tools, so locally and remotely. Locally, we have a nice graphical user interface for JMeter, so see the top of the slide. I mean, most people nowadays, they use a GUI, graphical user interface on top of their operating system, right? And yeah, why not for the testing tool? And behind the scenes, the partner, see the right-hand side, replies with some predefined SOAP, JSON, diameter, whatever answers. So remember the example. So with quality of service being lowered after a certain threshold is surpassed. Well, in this case, we are using the protocol diameter Rx to tell the PCRF to lower that quality of service. Using a graphical interface, so the point of this slide is that using a graphical interface is more user-friendly and allows the tester to conveniently run the test over and over again until it works. And when it works, now let's talk about remote testing. What changes is the way that we run the test tool. This time the test tool does not have a GUI, it is scripted, and this way we can do it for unattended runs. So nightly tests, similar stuff. This is usually done after locally you made sure that things are working properly. Okay, and functional testing of all components, that's complete flows, going through every component there is. This is done mostly for release builds. We have like 500 end-to-end tests for this solution. And in order to get a reasonable runtime, we are running, like I said in that earlier slide, 5 workers for nightly, and we are planning to use more, like 10 workers for the release, and may be able to scale up even more. Just as a time reference, a full run of 500 tests takes 1 hour and 19 minutes, 536 tests. But they are complete tests and they take a while. So, having discussed this pipeline and seeing how it all applies to this sample project, we come back to this reliability issue. So see the bold text in the slide. Scripts, sometimes like Cinderella, they receive very little attention by default, not to mention the whole review, test iterations. I'm not sure why, but I guess people tend to consider them a temporary solution. But as we all know, temporary solutions tend to become permanent. And this is where Scaffold comes in for us. Scaffold provides the pipeline, albeit more standardized pipeline, and without the use of classical, let's call it classical scripting. So we don't have to script it ourselves. This tool will do it for us, and it will replace most of our in-house Jenkins pipeline. For the Java compilation specifically, since we are talking Java here, there is the jib builder, see the bolded line. And this takes care of either Maven or Gradle. The rest, like the Docker build and the Kubernetes deployment, are native Scaffold operations, meaning they are available by default. You don't have to do anything special. And since we discussed about running the current deployment locally or remote, so these are the profiles that we use for Scaffold. We have 2 profiles, one for nightly builds and one specific for testing the statistics. So just one more thing, coming back to the basics. What if you need to do a fix which you cannot quite get it? I mean, you have a regex is misbehaving. You need to do several fixes in order to find out which one works. So using the Scaffold for us in the dev mode, you can task it with monitoring your source code. And whenever there is a change in the source code, the build pipeline is automatically run again. So this allows you to have the local environment, thanks to, of course, Docker for Windows or whatever you are working on, with all the necessary dependencies around the component that you are debugging, all of them in pods. So back to our list of problems, we've crossed out 2 more. The Java compilation time, this is not directly solved, but having a quick turnaround for testing a new fix does really help. And one more problem solved, debugging a component by running it locally with all the other components around it. So the point of these last few slides is that what we are trying to do is making sure that we have a complete testing environment with local testing, with remote testing, with GUI, graphical user interface for the local testing, and we have remote testing with scripts in order to have a reproducible environment so that one error, once noticed, will be reproduced again and again. So instead of conclusions, for us, moving Java code to Telco Cloud has been about using a collection of tools that have been vetted, and alongside them, trying new ones like all the time. Their use depends on the size of the project. They may work for one, but not the other, how old that project is, what are the customer's priorities, as well as your own priorities. So, another reminder about the tech quiz, where you can win these 3 vouchers. And thank you. And if there are any questions.
Thank you as well, and congrats. So I very much enjoyed the way you structured the presentation. So you've been very goal-oriented, started with a list of issues that we had in mind, and then one by one you tackled them all. That's great. Still, what would be, I don't know, the top 2 or top 3 list moving forward? Because I can't imagine that these are all your problems, or were your problems, and they are solved.
Okay. So one of the problems is, one of the goals moving forward is to be able to shrink it down. So in the end, like we have seen in the previous presentation, and I'm sure other presentations as well, you want to be able to recreate your code, move it to something that is that adheres to the current rules. So have single interfaces and so on. That is the end goal. So being able to unit test everything will bring a huge advantage. However, that is an ongoing process, not just for this project, for any other project which has code that is not completely newly written. So
And
rewrite
nothing is
is a
completely
goal.
newly written, right? I mean, in 3 months, 6 months,
Yeah,
nothing is new anymore.
precisely. But the idea is that if you write it now, you will try to stick to those principles.
Yeah.
So every new code has to be written properly to be able to be unit tested and functionally tested, and have mocks and simulators for everything around you. Because mostly, especially in the telecom world, you don't always have access to the real equipment. The real equipment is expensive, it requires a lot of maintenance, and you are much better off with a simulator.
Mm-hmm.
But
Okay.
the quality of the simulators is very important for the outcome.
Okay, so good luck with your list of enhancements. We've got 2 more tiny questions in closing. First one is related to OpenShift, if it can operate independently of cloud resources.
Of cloud resources, if I need to replicate a particular use case locally, yes, that's the point. I mean, everything that we run on OpenShift should and actually does work locally. So everything that you do in OpenShift, you can do in your Docker for Windows, whatever. So we have no dependency on cloud resources. I've seen a lot of presentations where this is an issue. So using cloud-provided services like a database or something like this, because you tend to get locked into such services. We don't. I mean, by the nature of telco, we usually don't have this chance. I don't know if I want to call it a chance. It's yeah.
It's just different, I would say. But yes, sometimes
everything,
you just get locked down into some services, to some platform, and that's it.
Yeah. So everything we do on one server can be replicated, on one cluster can be replicated locally.
Okay, thank you. And there is a more specific one. I kind of lost the context for this, but each worker has the same version.
Yes.
Yes,
okay. That is correct. Each worker has the exact same copy of the whole solution. Each worker has 9 pods currently with all the 9 components of this system, application, whatever.
Excellent, Mihai. I really enjoyed this conversation. We should do it one more time.